where you find your switch are dissimilar, which means they're not similar. So we're going to use on interfaces and then an applet interface. And then obviously our cloud, depending on the layout for the cloud, can let me see what I have for the cloud over here. Modules. Let me incorporate one interface on that. Okay, so power device offers. I already have one interface. Oh, power outlet. So switch it off first, and then you can attach the covers. Okay, so let me power it back up. So that's my cloud, generic cloud. So I can connect to an ISP. So I want to use an straight through that to internet. Okay, great. So we've basically put all of this into our simulated environment. Now, we need to incorporate our IP schemes. Okay, remember we were using the 192.168.10 as our network address and for IP scheme. Yeah? And as I pointed earlier on, you can configure devices either statically or dynamically. And in this scenario, we want to make sure all these end devices here are configured with DHCP dynamically, whereas fixed devices are configured statically. Okay, so we're going to start out with the server, and we'll configure configuration. We'll configure our IP address for our server statically, so static, and the IP address is 192.168.10 subnet, sorry, network address .5, and then /25, which is 255.255.255.0. Great. So it's assigned, it has its static IP address. Now let's go to services. The server we have here have got all kinds of services that it can offer, from web services, DHCP services, TFTP for storing your config files, DNS, syslog, AAA authentication, time protocol, network time protocols, emails, FTP, IoTs, and whatever. Okay? And then radios notifications. What we're interested in right now is the DHCP part. So as we mentioned earlier, we want to make sure that our IP address starting point is 200. So obviously, if you notice, it has already embedded the network address here for us. We want to start from 100, and then with a subnet mask of that. And our gateway is going to be our router's IP address, which in this case 192. So please, what cable termination can be used for a router and a router? Okay. Let me finish this. I'll get to that question. Okay. Obviously, router to a router are similar devices, so you can obviously guess what the answer to that question is. Let me just finish this real quick, and I'll come back to that. 192.168.10.1. That's our router's LAN IP address. And we're going to set the DNS as the same to itself. That's 168. That's 10. That's 1 as well. Okay. So once the service is configured, we need to enable it by saying service on. So now it's on, and then we save. So now it gets saved into your pools. Okay. Now I'm going to turn it off for now, just for illustration purposes. And then I'll come back to assign an IP address to the printer. Printer's interface static IP address. It was 192.168.10.6, right? It was 6. And then subnet mask is blah, blah, blah. Okay, so that's the printer. So the printer is also configured. And then our wireless router. Our wireless router config interface. The LAN interface is supposed to be 5. So it was 10. That's 2. Okay, great. And Wi-Fi is already set up. Okay, great. So our LAN has got that IP address on it interface, and internet-wise, will practically pick up the connectivity. It also indicates static from the internet. Okay, I've seen it's coming from the router. Let's forget about that part. Okay, so our access point has got an IP address as well, which is the 6. So right over, so the 2, it's right over there. Okay, so we do have our static IP addresses on these guys. Now we're not doing that. It's just a flat network. Okay, so we're not doing this. Please, what about cloud to wireless router? No, we're not doing that. It's supposed, because the wireless router is supposed to be within our internal network. The very moment you connect to the cloud, then it's out of your network. Nobody plays the access point on the cloud side, on the ISP side. They place it within the organization. Okay, so Joseph, the answer to that question is no. It's supposed to be within your organization, not at the cloud side or the ISP side. Okay. Okay. So coming back to the router to router cable option. Usually, when you're connecting devices that are similar, you use crossover cable. So a router to a router crossover. A switch to a switch crossover. But devices that are dissimilar, like a switch to a router, or a switch to a PC, or a switch to a server, or a switch to a printer, these are dissimilar. You use the straight through cables. But today, the Ethernet port design has been restructured to be smart. The keyword here is smart. To auto-negotiate between crossover and what? Straight through. Okay? I think all network Ethernet ports on any network device, either a computer, laptop, switches, routers, from the 2000 have all been programmed to be smart, meaning that they can auto-negotiate between crossover and straight through. So in that sense, today, you don't really have to worry so much about crossover or straight through cables anymore, because your Ethernet ports have already been configured to be smart, okay? Because of their auto-negotiation configuration that they've added to it. All devices that have got Ethernet ports from the year 2000 up to date, they would all have that smart interfaces. But if you had a device that was made before 2000, in the 1990 something, the 1980 something, or whatever, those are not smart. Those you'd have to go back to the crossovers and the straight through for similar and dissimilar devices. So I hope that answers your question. Who was that? Calvin. I hope that answers your question. Okay. Okay. So guys, today the whole concept of crossover for similar devices and straight through for dissimilar devices doesn't exist anymore, simply because of what the auto negotiation they've configured, they've designed and built into our Ethernet cards or interfaces these days on pretty much every single device that was built from the year 2000 to date. I've got auto negotiation on it. Okay. But if you went to buy an old device that was made before the year 2000, I guarantee you'd have to go back to the straight through for the similar devices, and then the crossover for similar devices. So keep that in mind. Okay. All right. So back to our IP setup. So now that I have all the IP address set up for some of these key devices, and I've not enabled DHCP yet on our server, let's just do some. So anyway, if you don't want to configure DHCP on your server, you can assign that option to assign static IP address to all these devices manually, and that could be tedious. So ideally go with a DHCP server. And let me also point out this: always implement or set up your DHCP servers on a separate server. In some organizations, they actually implement their DHCP servers on the router. And as a professional, you're not supposed to be doing that. And there's a reason to that. The reason being that a router's job is to forward packets from an internal network to another network or to an external network. That's what it was designed for, to forward packets back and forth. The very moment you start adding other services like DHCP, DNS, then you start overwhelming the router. Okay, and basically the router start getting its performance levels start going down. So if you're supposed to be getting maybe a throughput of say 95%, you might be getting about 75, 65, going, depend on the kind of services you've added to the router. That's why it's not ideal to do that. But the very most start adding other services beside forwarding packets on your router, its throughput start degrading, basically. Okay. So ideally, always install a DHCP server on the side to handle that DHCP request services, and just let your router handle pure routing. And you're going to notice huge significant throughput within your network. Okay, guys. So anyways, with that said, obviously these guys don't have any IP addresses, but the printer has an IP address and the server has an IP address. We're yet to configure the router part, and then the Wi-Fi also has an IP address. So let's try and see if we can ping these devices. So I'm going to be on the server here, and I'll try to ping. I will try to ping the whatchamacallit, I'll try to ping the printer first. So ping the command to check whether a device is alive or test connectivity between two devices is the ping command. So 168.10.6, enter. And if you know it's responding, whenever you see this, it means there's a connectivity between the printer or between two devices, in this case, server to the printer. You want to see sent packet 4, received 4, lost is 0. So that's it. That means all 4 packets. These are the packets. These are just basic packets that was sent. And you can also have the time that it was sent. A round trip in milliseconds, a minimum of 0 milliseconds, a maximum of 4 milliseconds, and an average of 1 millisecond to send all 4 packets from the server to the printer. So obviously we know this communication between the printer and then the server. But obviously there's no communication between the server and the PC server because they don't have an IP address yet. So now let's go back to the server and then enable the DHCP server services. So I'm going to just click on and I'm going to turn on this setup, save. So now, before that, let's test something first, just to make sure. So let's go to this PC here and check if it has an IP address. Obviously, it's going to have an IP address. So if you do an IP config, which is what you use to check the IP configuration status on the interface of a computer device. And as you know, it's all zeros. Physical interface, I've got all zeros because you don't have any IP address. Okay? Even if you did a renew, it will still not be able to put anything. See? Nothing. Oh, okay, so it's enabled. Okay. Because I enabled the DHCP, it's showing up now, which means my DHCP wasn't did I save it? Okay, so it's picking up IP address from somewhere. Let me check this guy over here, see what's going on. Looks like our router is trying to issue out some connections, some IP address, which it's not supposed to be doing. Okay, let me try it again and see. IP address renew. It's still picking up IP address from somewhere, which means that this, for some reason, it's not off. It's still saying it's on. So save, add, it's already add, save. I've turned you off, so I shouldn't be seeing an IP address. I've disabled DHCP basically. Okay, let me check again. Let me release. So I'm releasing the IP first so I can all zeros, and then renew again to see if it will show up anything again. It's still picking up an IP address. So obviously it looks like the DHCP server is been off from just the initial setup. It's allowing IP address requests to go through. It's quite interesting. So anyways, if you did have the DHCP server enabled, then the device will start acquiring IP address like this guy did. So this guy got, I'm going to renew, release, and renew. So it picks up 100, which obviously is supposed to be the starting IP address. Okay, and then the second PC, command prompt. Initially, it wouldn't have any IP address. once you do a renew, the renew is to basically release an IP address from the DHCP server. So whenever you type this command over here, ipconfig space /renew, it sends a request, a broadcast request out onto the network, demanding for an IP address. And then the server, DHCP server, will send a reply back and says, hey, I am the DHCP provider on this network, and I can lease an IP address to you. Okay? So when that happens, then it assigns an IP address to the device that requested for it. So now there was a release sent out, and it got the 101. Okay? So the request sent out, and then the DHCP server released an IP address 192.168.10.101 to the second PC. And the third one, the same approach. Command prompt, ipconfig, nothing. Space renew, it will pick up 102, 102. The fourth PC, ipconfig, nothing. Renew, we'll pick up 103. The last test PC, IP config, nothing. Renew, something. And then the laptops as well. ipconfig, renew. Oh, we have 99 students. That's pretty good. I hope you are paying attention. And following along. Let's renew. Okay, so all of our devices do have an IP address now. So now, assuming I was here or on any of these devices, let me see if I can reach the server. And the server, keep in mind, the server has got an IP address of what? 192.168.10.5. So let's run a simple ping to it. 192.168.10.5, right? So it's responding. So that's a good thing. It means PC0 can talk to the server. What about the printer, which is 6? The same thing, it's responding. So that's a good thing. And then what about the wireless device, which is .2, right? Also responding. So our Wi-Fi devices or our Wi-Fi AP is also responding. So that's great. It means basically, it means for as long as all these devices are on the same network, they are the same, the first three are also the same, then they can all talk to each other. Okay? Great. So now let me ask you guys if you're on the same page with me. I'm going to ask you guys to unmute.
We are lost. We are lost.
Where are you lost at?
We are lost.
Where are you
Simulation aspects.
We are lost. We are
Go back. The simulation is a bit confusing with all the IP addresses and stuff like that.
Well,
That's
because you didn't take your IP.
not get Cisco router then.
So please can you go over?
So from what I'm just getting from you guys, it means that most of you did not take your Datacom 1 IP subnetting class seriously. That's the reason why you're confused. Because what I did was pretty much just setting up an IP address scheme from what we had over here on the design over here. I'm just applying this IP address scheme onto our simulation environment. I'm allowing my server to handle the DHCP configuration. So I don't know where you got lost at. When you click on a server and you go to services, you should see these services. You're interested in DHCP. Click on it. Your gateway, default gateway should be the router's IP address, which is the 192.168.10.1. And the same applies to its DNS. So the same IP address. The starting IP address we set on the diagram here that it should start from 100 and end at 200. So that's what I've done. 192.168.10.100. Okay. And then when I was done, I just click add and save. When you add, it should show up over here. That pool, the name of that IP pool should show up over here. And then save it. So every time you make any modification, you save it. And then once you're done, you make sure you enable the DHCP services by clicking on the on button. So once that is set up, automatically, when a device, when you do an IP config space/renew on any of these devices, automatically they will request for an IP address from the server. And then the server will start issuing them out the IP address. So when we started with the first one, it got the first 100, the first starting IP address. Okay? So it picked that one up. The second one got 101, 102, 103, 104, 105, 106. There we go. And then this were all statically configured because they are fixed devices that do not need their IP addresses changing on a regular basis. So the guy's confused about the IP address. That's how I went about it. I didn't do anything magical. I just went to the server, when I got to DHCP services, made sure I had my gateway set up. The same for the DNS, just repeat the same IP address, and then starting IP address point. And then for the static IP address configuration, you'd have to go to Config tab, and then click on interface 0, and then you assign your static IP address to it. The server must have a static IP address, which is the 192.168.10.5, as we indicated over here, that the server should have 192.168.10.5/24. That's what I did over here. So make sure your interfaces, so you're going to be operating between the config and then the services. So make sure first you have your interface IP address set up, and then move on to services and go to DHCP, and then handle your IP distribution starting points and your default gateways, add and save, and then enable the service. So that should get you going. There's nothing like a local IP address. It's private IP address. Calvin, we don't have a local IP address. It's private. The correct word is private IP address. So we're using private class C IP address for our LAN or for our local area network interface or site of the network. Okay, Calvin? I hope that answers your question. Yeah, it's the word is the correct word is private class C IP address, not local IP address. Okay, because you can have a local IP address that is public IP address, and a local IP address also what? Private. So to get the differentiation correctly, use the technical words, which is private and public. So here we're just using private IP addresses from a class B session of the IP classes.